we are going to be looking at chapter 2.6, limits at infinity. So we are going to be evaluating this problem when x approaches infinity. So that is the square root of x squared plus 4 minus 3x over 4. So the first thing we're going to do for this is to multiply by the conjugate of the numerator. So multiplying, this is the conjugate of the numerator, and it's essentially multiplying by 1 because the conjugate over the conjugate is going to be equal to 1. And so then that simplified, or divided, or multiplied out is going to look like this. And when you subtract 9x squared from x squared and then add 4, it is going to be equivalent to this. And so then you can factor a 4 out of the numerator. And then when you cancel these 4's out, this is the equation you are left with. And so your next step is going to do what you can do with problems where x approaches infinity, which is divide by the x with the highest degree from the denominator. And in this case, it is going to be x, because from this equation, this x has the highest degree, but which is equivalent to this x, because although it's x squared, it's in the square root sign. So the square root of x squared is equal to x. So you're going to divide each value by x, as you can see here, and then apply the limit to when this is simplified. So x squared over x squared is equal to 1. An x cancels out, leaving negative 2x, and the rest you can see. So then as this x going to infinity is applied, you can see here that the limit as x approaches to infinity is applied to each value. And then this is what it is going to look like. And so this is negative infinity because when you multiply negative 2 by x as x approaches infinity, it is going to be negative 2 times infinity, which is negative infinity, as you can see there. And then this and that are going to be zeros because, which are these two values. So as x goes to infinity, when you have 1 over x, this x is going to go to infinity. So 1 over infinity is going to be 0 because 1 over a very large number is going to approach 0. And same for here. 4 over infinity squared is going to be x approaching, this is going to be x approaching infinity, so it's going to approach 0 because 4 divided by a very large number is going to approach 0. And so this is going to be 1 because you have no input of x when you take the limit of x approaching infinity of a constant. So this constant does not change because you have no input of x. So this 1 and this 3 are going to remain 1 and 3, as you can see. So when you simplify that, you are left with negative infinity over the square root of 1 plus 3, which is equal to the negative infinity over 4, because the square root of 1 is 1 plus 3 is 4. And that is equal to negative infinity because negative infinity divided by a small number such as 4 makes no difference, and it is just the same as negative infinity. So this is going to be your solution when you take the limit as x approaches to infinity of this. Okay, so for our next problem, we will be evaluating the square root of 3x squared plus 4 over 5x minus 3 when x approaches negative infinity. So when x approaches negative infinity, you can use these rules because x is less than 0. So you will see how these apply in a second. So the first thing you're going to do when evaluating this is you are going to divide each value by the x with the highest degree from the denominator. So in this case, the only x in the denominator is x, and so its degree is 1. So you're going to divide each value by x. But in this case, you're dividing by negative x when it's not in a square root because your x goes to a negative infinity. And so then that negative infinity applies to that x, so therefore it's negative x. and it is x squared because that is equal to negative x is equal to the square root of x squared. And the square root of x squared is plus or minus x. And so in this case, it's going to be negative x because x goes to negative infinity. So then you divide each value by negative x or x, the square root of x squared. And then that is going to equal this. So these x squareds cancel out. You're left with 3. These x's cancel out. You're left with negative 5 and so on. Then you're going to apply the limit of x going to negative infinity to each value from your previous, what you got previously. And so then you're going to get the square root of 3 plus 0 over negative 5 plus 0. And these are both zeros because you have a small number over an infinity. And so when you have that, you're dividing a very small number by a very large number, and so it approaches 0. So that is the case for both of these. And then these are both remain the same constants because you're taking the limit as x approaches negative infinity of a constant, and you're not inputting any x. So this doesn't affect that value. So then you simplify this and are left with the negative square root of 3 over 5.